Hey everybody, welcome to Geometry, Section 6.6, Trapezoids and Kites. By the end of this lesson, you should be able to understand what defines a trapezoid and a kite, make application of the properties of each shape, and use the properties of each shape to create and solve algebraic equations. So, what is a trapezoid? If you recall when we did that big Venn diagram, we did, here's all the polygons, all the shapes with straight edges. And then we talked about specifically quadrilaterals, which is four-sided figures. And then inside of that, we did parallelograms. Well, four-sided figures that aren't parallelograms are either going to be a trapezoid or a kite, okay? Or just a random four-sided figure with no shape to it at all. Okay, so that's what we're going to be doing is trapezoid and kite. And everything that we learned about parallelograms does not apply to these two shapes. So let's talk about it. What exactly is a trapezoid? A trapezoid is a quadrilateral with exactly one set of parallel lines. So what that looks like is something like this, where you can see that the top and the bottom are parallel, but the two sides, the legs, are not parallel. So yes, the two sides that are parallel are called the bases, and the two sides that are not parallel is called the legs. Now this can look a couple different ways. This is typically how we see a trapezoid, something like this. However, we can see something like this where the top and the bottom are parallel, but there's a couple right angles in there. Okay, that's called a right trapezoid. Or a situation like this where the top and the bottom are parallel, but it doesn't look like what we typically see. This is what's known as an obtuse trapezoid. Okay, we rarely see those, but I just wanted you to be aware of them. So, properties of a trapezoid is that consecutive angles are supplementary. Now, if you recall, consecutive angles or same-side interior angles from Chapter 3 look something like this. Now, if I just drew an extra line in there, all of a sudden I've got a trapezoid. Okay, so angles 4 and 6 are still going to add up to 180. So are these two angles over here, angles 9 and 10. Those will also add up to 180. Now, 4 and 9 will not add up to 180, neither will 6 and 10. It's only the consecutive angles along the leg, along the non-parallel side. Those are the only ones that add up to 180. So an example problem might be something like this. You might look at it and say, okay, it's a trapezoid. We got one set of parallel lines. So I would know that 2x plus 32 plus 112 equals 180. I would also know that y plus 46 equals 180. So those are the main equations you would need to set up in order to solve those. That's the main idea I want you to get from this. Of course, we can do some algebra and work this on out and figure out what each of those variables are. But the idea I want you to get is these two consecutive angles add up to 180. Now, a special kind of trapezoid is called an isosceles trapezoid. So we know what an isosceles triangle is. It's where the two legs are the exact same length. Well, similar idea in a trapezoid where the two legs are the exact same length. Okay, so it's almost like a big isosceles triangle with the top cut off of it, where the two sides are the same. Now, if those two sides are the same, some special stuff happens here. So these two base angles are going to be the same, just as in a triangle, and these base angles up top are also going to be the same. So if I know one angle, I know all the angles. So if that angle is 115, then I know that this one over here is 115. And then because I know that these two add up to 180, if that's 115, that's got to be 65. And if this is 65, then the other one's also 65. Now, in this case, this is not an isosceles trapezoid. If I know that this is 72, I know that this angle up here is going to be 108. But that does not translate over to the other side. I have no idea what x is, okay? So yeah, 108, that's the only thing I can figure out from here. But I got no clue what x is. So we know that in a trapezoid that the legs are congruent. We know that the base angles are congruent. We also know that the diagonals are congruent, okay, just as in a rectangle. So in this diagram, I can see that it's a trapezoid because I got the one set of parallel lines. I know it's isosceles because of the two dash marks. And I will now know that AC is congruent to BD. Now, when that happens, there's all sorts of stuff that you need to know. The diagonals are congruent, but also this mini part of the diagonal is going to be the same as what's up here. And likewise, the bottom part of the mini diagonal is going to be the same as what's down there. Okay? Now, because that's the case, up here I've got a isosceles triangle. So I know that this base angle is going to be the same as that one. Down here, I know that this base angle is the same as that one because, again, another isosceles triangle. So here's another example problem. It says DF is 8.7. So that full diagonal is 8.7. Find EG. Piece of cake. EG is 8.7. Okay, so that's been a lot. So let's just go ahead and slow it down for a second. Now let's talk about something called the trapezoid mid-segment theorem. And what that says is if I find the midpoint of this leg, so you can see P is right in the middle there, and I find the midpoint of this leg, so Q is right in the middle, and then I connect it, that makes PQ the mid-segment. So it's just connecting one midpoint to another. So what you should know is that the mid-segment is parallel to both of the bases, and that the length of the mid-segment is the average of the two bases. If you recall from previous math classes, average just means to add them up and divide by 2. So let's take a look at a few examples here. All right, so here we have a few examples of some trapezoids with the mid-segment. So in question 7, it asks us to find the length of AB. So if you recall, I told you that in order to find the length of that, you just add up the two bases and divide by 2. So 9 plus 13 is 22. And so that makes the length of AB 11. Oh, that's an ugly 11. Okay. Let's do the same thing for question number 8. I'll add up the 5.5 and the 12.9 and divide by 2. So that's going to make 18.4, which turns into 9.2. Okay. Now, they'll also kind of twist this theorem on you and see if you can figure out one of the bases. So here, on number 9, I've got one base to be 13. The mid-segment is 19, but I don't have the second base. So here's what I'm going to do. Here's one way to do it, and I think this is the long way of doing it. I'll take 13 plus x and divide it by 2, and that will equal 19. Okay, so I'm still adding up the two bases, dividing by 2, and that's the length of the mid-segment. Now, to get rid of that fraction, I'll multiply by 2. So that's 38. And then subtract the 13 from both sides, and I get 25. That's the long way. Let me show you what I think is an easier way of doing that. Okay, so the short base is 13. How do I go from 13 to 19? I add 6, right? So then to go from 19 to the other base, I'm going to add 6 again, and I get 25. That, I think, is a lot easier. Let's try it on this one over here. How do I go from 4.4 to 5.5? Well, by adding 1.1. So let's add 1.1 again, and I will get 6.6. All right, now this looks like a mess. Okay, how can I figure this out? Well, I can't do the what do I add to 10 in order to make it 20x plus 4. what I'm going to have to do instead is I'll have to do the old way, the tougher way. I'll have to say that 10 plus 24x plus 6 divided by 2 equals 20x plus 4. To get rid of the fraction, I'll multiply by 2 on both sides. So I'll get 40x plus 8 over here. And then that 2 is now gone. And while I'm at it, can I just go ahead and add the 10 and the 6? Okay, now I can do some algebra, subtract the 24x from both sides. Subtract 8 from both sides. Divide by 16, and I get x equals 1/2. But they're not done with us yet. We've got to figure out the length of TR and MD. So if I take that 1/2 and I plug it in, I get 12 plus 6, which is 18. And that was TR. Let's plug it in for MD. So 20 times 1/2. So 20 times 1/2 is 10, plus 4 is 14. So let's see if that little trick that I did up here where how do you go from here to here and then do the same thing to get to the other base? How do I go from 10 to 14? I add 4. And then if I add 4 again, does it get me 18? Sure enough. So that's proof that I've done it correctly. Okay, so now let's talk about kites. So a kite has 2 sets of consecutive congruent sides. So what that means is in this quadrilateral, a 4-sided figure, I'll have one set of congruent sides and then another set of congruent sides. So here on this SpongeBob kite, you can see that these top 2 sides are the same and the 2 bottom sides are the same. All right, now there's no way that these 2 sides could ever equal those sides and make it all 4 sides because that would make it a rhombus. So 2 sides next to each other are congruent and then 2 sides next to each other are congruent. That's what defines what a kite is. So one of the properties of a kite is that if you draw the diagonals, they'll be perpendicular. They'll make 90-degree angles. So just like a rhombus, but it's not a rhombus. It's just that they both have the same characteristic. Okay? So one aspect of that is that it creates 4 right triangles. So all 4 of these triangles in here are right triangles. And hopefully you should know that if you see right triangles, there's a possibility that you're going to be using the Pythagorean theorem to find some of the lengths. Also, the kite creates 2 isosceles triangles. So triangle ABC, this big triangle at the top, is isosceles. And angle ADC, this other triangle down here, is also isosceles. So because those are isosceles triangles, you should know that there's going to be some congruent angles in there. Also in a kite, you have one set of opposite angles that are congruent. So big angle A is going to be congruent to big angle C. So here's an example of a kite. And because it's a kite, I would know that angle N is congruent to angle Q. Now I've went ahead and taken a time to make a diagram here that shows you what angles are congruent. So I've also kind of flipped it so it looks like a traditional kite like we see flying in the sky. But kites are symmetrical. So what you see on this right side is also going to happen on the left side. So the blue angles are congruent, the red angles are congruent, the 2 green angles are congruent, and the 2 pink angles are congruent. Now the reason I didn't make the top part red and blue is because what happens in the top part has nothing to do with what's in the bottom part. So no angle up here will be congruent to an angle down here. So let's take these property of kites and put them into action. So question number 1, it asks us to find out the perimeter of this kite. So here's what I know. If that side over there is 12, then I know that this side over here is also 12. If this bottom side is 20, then I know this other bottom side is also 20. So if I add those up, 20 and 20 make 40, plus another 24, that makes 64. All right, number 2, we need to find both x and y. So let me zoom this in a little bit so we've got some room to work. All right, so here's what I know about a kite. If this is 18 degrees over here, then I know that this is 18 degrees. So I'm just putting the 18 in the same triangle with the x. I also know that this is a 90-degree angle. So add up the 18 and the 90, subtract it from 180, and I have that x is 72. All right, I'll do the same thing with the y's. If that's 29 degrees, then I know that this is 29 degrees. I also know that that's a right angle. So I can add those up and subtract them from 180, and I can tell that that's going to be 61. Now here's another interesting fact. This y and this 29, those will always add up to 90 degrees. Okay? This x and this 18, those two angles will always add up to 90 degrees. Okay? So let's check this out. It tells us that the kite's perimeter is 86 feet. So let's go ahead and figure out, okay, if this is 3y, then this is 3y. If that's 6y minus 2, this is 6y minus 2. So if I add all that up, it will equal 86. So add up all the y's, add up all the other numbers, add the 4, divide by 18, boom, I've got what y is. Now to figure out what x is, remember I told you that a kite is symmetrical? So that means that this side over here is the same as this side over there. That part of the diagonal and that part of the diagonal. So I know 5x minus 15 equals 2x plus 3. Then do some algebra work, subtract the 2x, add the 15, and boom, I get x equals 6. All right, number 7. So I know a kite is symmetrical. So if this one angle up top is 146, then I know that y is 146. Now, remember how I told you that stuff at the top has nothing to do with stuff at the bottom? That's true. However, that's mainly when we draw diagonals. If we don't have the diagonals, this is still a quadrilateral. It still has a grand total of 360 degrees. So I'm going to add up what I have. So 146, 146, and 47. We're looking at what? 341, I think. So then I'll say 341 plus x equals 360. Subtract the 341, and boom, I get x equals 19. So the trapezoid and the kite, they're a little bit different, but once you get the hang of them, they're not bad. So if you guys have any questions, please feel free to email me, ask questions in class or in a Google Meet, and I will see you guys as soon as I can. Have a good one.